you apply some oil layer or some grease layer, then you are going to drag the block on that particular. So there's a oil layer. Or on pizza, you apply sauce and you keep some paneer cube and you are dragging it. Anything it can be, need not be always this much only. This won't block everything. It can be anything, no? Tell me like how the viscous drag will act. It will be in this direction. Because the velocity of the block is towards right now. So you should oppose relative motion, so viscous drag will act here. So to move that block with a constant speed, I must apply external force, which is equal to viscous drag. What is viscous drag? Eta, area of cross section, L square. Velocity of the bottom of the cube block is V. And what is the perpendicular distance? It is D. Negative sign, why we are bringing is like in the formula to show that viscous drag will oppose relative motion. But here you don't put negative sign because we are calculating magnitude. What is the power action agent should generate? How much of power? F actional into V. So eta L square Vd into V. Fine. This is the simplest examples I'm giving. Sir, I will drag a. So instead of this, what happen? I will instead of oh, what happened? No. Let me bring some other body. So here, let me bring a disk. Circular disk, let me drag it. Tell me like how much of actional force I should apply. So what is the circular disk here? No, will appear. What actional force I should apply? Then F actional equal to eta. What is area? Pi r square. Velocity is V. Viscous drag will act like this into D. Able to understand, no? The area of contact. Very easy formula, sir. You need not to bother anything very big here. Able to understand this one? Okay, let me introduce to the other problems. Okay, this is the oil layer. I have to show thick, no? Let it be. This is some oil layer. I'm showing it. Some rough diagram. So let the dimensions of the block, let it be L, B. What is the conditions? How do you write it now? So here, the moment I release, weight M2G will act. Then the tension T. Here the tension T will act. And the viscous drag should act in this direction. At an instant of time, let V be the velocity. Then acceleration of this should be equal to acceleration of this. Then what are the equations of motion? m2g minus t equal to m2a. T minus viscous drag should be equal to m1a. So what is the viscous drag? We write eta. Area is what? L into B. Small l, I'll take it. Velocity is V. What is the thickness of this? Let it be D. Oil layer of thickness D is formed on the table. Then on that, I'll place a block and I'll connect to a pulley and connect it to block here. This is the condition. So this should be equal to D, no? So eta LBV D. So let me substitute here. This will be eta LBV D equal to M1A. I'll add up these two. M2G eta LBVD is equal to M1 plus M2 into A. What is A? A is dV by dt. Get ready for all mass-based problems. What is A? A will become dV by dt. Agree this one? So this will become, I want expression for velocity. So let me simplify for this. So this will be m2g by m1 plus m2 minus eta lbv d m1 plus m2. Let me take this alpha, this is beta v dv by dt. What is alpha? m2g by m1 plus m2g. What is beta? All that parameters, eta, lb, d, m1 plus m2. So this equation will end up at t equals 0. Let me release from rest. At an instant of time, this will be. So then what is the mathematics here? No? Minus 1 by beta log of this negative sign, send on this side. Okay, no. So this is the, so just mathematics. Huh? The viscosity idea is very simple here. The continuity, I'll show like this. Huh? It'll be easy for you. We are. Okay, no? No. So what is the next thing you can write? Send log on that side. So alpha minus beta v by alpha equal to e to power of minus beta. So this will become alpha into v is equal to alpha by beta. So this is expression for the velocity of the block or velocity of the blocks at any time t. You have to bring your mathematics into picture because the force viscous drag is a function of velocity. So then this will be the equation. So viscous drag depends on what? Area of contact. That's what is trying to bring it here. If it were a friction, no, friction what happen will be constant magnitude independent of area of contact. Here the viscous drag depends upon the speed, relative speed. Any of the questions, so it depends upon. So now in the viscosity chapter, what you have to give priority? What is that area of contact? It's something very important. And what is the distance D? The distance between the bottom of this particular block and the thickness of layer. I think the plane diagram, it will appear like this. Some of you are still getting confusion. This is what that layer. Able to understand now? At least this will be much easier. So what is the thickness? Will be D. So here tension, the viscous drag should act here. They make you plain diagram or they make you 3D diagram. Shall I slide down?